Okay, we're moving into section 2, and this again is under the same um, tested content in the keystones here. So we're going to multiply things that have the same base. Long story short, guys, we're going to add our exponents today. So we're going to add our exponents. In the previous section, we did zeros and negatives, and today I'm going to teach you when to add. So let's say that we have something that has a common base. For example, let's say that we have something that has the base of a. Well, what do you do with their exponents? You add their exponents, and then you'll be all done. Now, this example, I think the book gave you is kind of difficult, but it's like, now here we have a base of 4. So they're showing that you add your exponents to get your final answer. Now, they did that with fractional exponents. I think that's misleading because you're not going to be tested on the keystone on fractional exponents. So I've eliminated them out of the curriculum. But take a look at the example provided. We'll deal with the fractional exponents, but then we'll lose them when we start doing our own problems. So let's say that this is what's given to us. That's the problem. What I want you to notice is they multiplied the coefficients. So you see the 2 and the 3 and the 5. They put 2 and 3 and 5 right there. And then they put the a's beside each other. So you see how there was an a with an exponent and an a with an exponent? They put them here. And then hopefully you can see how there was a b with an exponent and a b with the exponent, and they put them here. That's called the commutative property of multiplication. And then they went ahead and multiplied all of their 2, 3, and 5s and got a 30. And then, let's see, they rewrote the other parts, so I'm not even going to bother with that. They just rewrote them. So what I want to show you here is that in order to get a's new exponent right there, they added the exponents from step 1. And in order to get b's new exponent right there, they added the exponents from step 1. And then the 30 just came down. So we're going to multiply our coefficients and we're going to add our exponents of our common bases. So here are the examples. I pulled them straight from the book and just retyped them. Here we have a common base. The base is 7. So I'm just going to write the word base so you get familiar with your vocabulary. So there's your base of 7. We need to add the 3 and the 4 because the bases match. Well, that's going to be 7 to the 7th power, which might be actually too big of a number for your calculator. Oh, not too bad. What do we have? 823, comma 543. So it'd be 823,543. So common base was 7. Add your exponents. Next, let's try the one right beside it. Common base is a 9. So what I'm going to do is I'm going to just box up all my 9 so you can see that was the base. There it is. And I'm going to add my 6 with my exponent of -4 with my exponent of -2. So there they are being added. So let's see, what is 6 add -4 add -2? And maybe you can do that in your head. That would be phenomenal. You get a 0. Oh, and then we have that neat rule from yesterday that anything to the 0 power, the final answer is just a 1. Let's try the next one. So we have to remember our rules from yesterday. So I have a common base of 5. So I'm going to write it here. And now I have exponents of this, 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 and this. So I need to add them. So I need -2 plus -4 plus 8 plus -2. Drop down all my exponents. So that's 5 to the, I'm going to use my calculator so I don't screw up, -2 plus -4 plus 8 plus -2. A lot of kids skip step. Is that a 0 again? That's kind of funny. All right, so anything to the 0 power is a final answer of 1. That just happens to be something I pulled from the book. That's interesting. Some kids really refuse to write this step, and I will tell you, like, those are the kids that get it wrong. So just take your time, write the step. I mean, it's worth getting a good grade. All right, so I have a common base here. The common base is m, and those vocabulary words I'm using, those are real words, so I'm going to say them. Common base of m. I need to take the 3 and add the 4, and that's going to be to the 7th power. I can't put that in my calculator because it's a variable, so I'm done. It's not like I can go over to my calculator and like, oh, where's the m button? Just don't do it. Even if you're like, I see one, don't do it. Just leave it alone. All right, so again, oh, look at this one. We're getting a little more difficult. So what I see here are coefficients. I see coefficients of 4 and coefficients of 2. I'm going to highlight my coefficients today in blue so you can see what happens to them. So there's my coefficients. Now I have a common base. I'll do my common base of t like this. So there's my common base of t. I'll highlight it so you can see the colors. Now I need to take my -5 and add my -3. So 4 times 2 makes 8, and -5 with -3 makes -8. Oh, and now remember from yesterday, we can't have a negative exponent. So the 8 stays put, and the t moves so that it can have, see this guy? He needs to move because he needs to end with a positive exponent. You must end with a positive exponents only. So if it needs to move, make sure you move it. The next one, coefficients. My coefficients are 5, 3, and 3. So I'm going to write 5 times 3 times 3. My common bases, let's see, I'm going to grab orange. I have x and x. So here's the x. I'll highlight it so you can see the color. The exponents on those were 5 and 2. So I'm going to need to do 5 plus 2 for the x's. I'm going to need another color on this one because I have another base of y. So here's my y, and its exponent was 6. And that was the only one of its kind. So that's the only y I need to drop down. So these numbers, these coefficients in the front, 5 times 3 is 15, times 3 is 45, 5.3.3. If you need to see it played out in the calculator, there it is. This will be x to the 5 plus 2 is 7, and y has a loner 6. All of those are positive, none of them are 0, so there's your final answer. Let's check out this one. So I definitely have a common base here. No coefficients, but I have a common base of m, and I have a common, that's it. And I need to figure out what in the world goes in this box so that this left side will equal m to the negative 9. So it's going to be m, and then to the whatever goes in that box plus negative 4. That has to give me m to the negative 9. So thinking backwards, what number plus negative 4 makes negative 9? Well, I know the answer is negative 5. If you don't, if you could call me over and get some help with that, I'd be happy to do that. So my answer in this particular problem is negative 5 because they were looking for what goes in the box. Just remember, whatever you put in the box, when you add it to negative 4, you have to get negative 9. So the answer to this problem is negative 5. Now we have another box we have to fill in. So let's see, we're going to have A, and then whatever was in my box plus a 4 has to equal a 1. So it's not like the box in 4 has to equal 1. The whole thing has to equal 1. So here's what I'm going to remind you of. Remember, I would need an exponent of 0. So what I'm going to do is I'm going to rewrite this. I'm going to just shrink this down. And I'm going to do, it would have to be a to the 0 power. So what would go in the box so that whatever you put plus 4 has to equal 0? Well, the box has to be a negative 4. Just remember, anything that you add, you have to get an exponent of 0 because an exponent of 0 makes 1. So in the box would have been negative 4. All right. Well, this one's kind of sneaky. Let's see. So I have a common base of x's. So I would have to have x to the 3 plus something. And I have a base of y to the something, and that would have to end up with y to the second. Now the question was, does anybody know, anybody watching my notes, anybody know what x would have to have a power of here since it disappears? Hopefully you would know x would have to have a power of 0 for it to disappear. So can you think what number would have to go in that box so that when I take this 3 plus this box, I end up with 0? Hopefully you guys know negative 3 is what goes in the box. Now, let's deal with the y. What would have to go in this box so that you end up with a 2 at the end? Well, since it's the only one of its kind, that green box would have to be a 2. So that one went a little bit backwards. If that wasn't explained clear enough to you, want some extra, let me know. Participate in class during that time because there'll be a few on the homework like that as well. All right, see you soon.